All right, good morning, cohort A. How we doing? Doing okay? Doing good? All right. Perfect. All right. Good attendance there. We have an interesting week this week. First of all, glad that you guys are back, cohort A. You guys do have your packet. This packet is going to take you through the end of February, so it is a very large packet. And you also have a polyatomic ion sheet. I personally just paperclipped my polyatomic ion sheet to the back of my periodic table because you don't want to like staple it or anything, because you do have some information on the back of the periodic table that could be helpful to you. But for right now, you always want to make sure you're going to need the periodic table and the polyatomic ion sheet after Wednesday almost every single day. Okay, so getting those two things together, and then you have the packet that I gave you. Okay, good. Now let's talk about the schedule first, because I have a little note to myself, because this week is kind of strange, being that you do have the PSAT tomorrow. Okay, if you want to look at the whole unit as a whole here, you can see that we're going to do this through February 26th. That's when your test is going to be. Remember, we try to keep you have two lectures on Monday, a lecture on Monday and Tuesday, and then on Wednesday is a practice day or something else synchronous. Thursdays are always going to be labs, and then Fridays are always going to be quizzes. So we're keeping that up just as much as we can. We do have a lot of school off in February. So if you don't have school on those Fridays, those quizzes will be on the Thursdays instead. Okay. So looking at this week, let's kind of zoom in on that bad boy. This is week 21. You will see that I did kind of consolidate the periodic table stuff up there. So if you do want it, you haven't finished it all, it is up there. It's all in that orange folder. But we're now in week 21 here. And let's talk about this week. So today we're going to do the atomic bonds notes, kind of dipping our toe into atomic bonds, atomic naming, stuff like that. Then tomorrow is the PSAT. Anybody in here taking it tomorrow? Sweet. Okay. So the PSAT is, we are proctoring it. So I will actually have students in this room. So I cannot have live class. You will be in one of these rooms, those of you taking it. So there is nothing synchronous tomorrow, but they're expecting us to put out asynchronous material. So tomorrow I will just make a video. I'll probably make it at lunch today, so that if you would like to watch it this evening, you're more than welcome to, or anytime tomorrow after you get back from the PSAT, because I believe it's over by about 12:15. Okay. Then Wednesday, usually it's a practice day. We're going to throw one more kind of little short lecture on Wednesday. Thursday is our lab and class. We're going to try to teach you guys how to light the Bunsen burners. And then we have what's called a solution situation. Those of you at home will not be coming Thursday, because you don't come on Thursdays because we have in-class stuff. And then Friday, there is the quiz. So Monday, live class. Tuesday, lecture. Wednesday, live class. Thursday, if you're not here, nothing. And then quiz on Friday. Okay, perfect. So that's kind of where we're headed here going on. Let's get into these notes then very quickly. A couple things you should know coming into these notes. You should know that metals give away their electrons and become positive. Non-metals take electrons and become negative. We're going to really capitalize on that today. And then you do need to know how many valence electrons each element would have. We're ignoring this block down here. We'll ignore that for a while. And then everybody except for helium has that number of valence electrons, whichever is the top of its group. Okay, awesome. So if you have that information coming into this, here we go. Now, one of the main things is very important in chemistry is that elements tend to form bonds. There are two main types of bonds we're going to talk about in this year. There's a few other types of bonds, but there's two main ones we're going to talk about. The rest is for AP. There's ionic bonds and covalent bonds. So today we're going to talk real general, just bonds in general, and tomorrow we're going to get into more specifically ionic bonds. Okay. So what is a chemical bond? A chemical bond is when atoms join together chemically. And why do atoms want to do this? They need to become stable. Okay. Sometimes it's a very violent reaction, sometimes it's not, but all atoms are trying to become stable, so they'll enter into chemical bonds. Okay, might be a lecture question coming at you here in a minute. In order to create a bond, the only thing that can be transferred back and forth between electrons, the only thing are between atoms are electrons. Okay? Electrons are either transferred, which means you give or take. Okay, so I'll give you an electron or I'll take your electron. Or when we talk about covalent bonding, electrons can be shared, but we'll do this in the spring. Okay, that's called covalent bonding. And once you either transfer or share electrons, then you become a new chemical. Like we talked about salt in the matter unit. Salt is NaCl. It's an explosive metal and a deadly gas. But once they transfer their electrons, they're delicious on French fries. Okay. Awesome. So the biggest thing, they do it to become stable. And what you're trading are the electrons. Now, what electrons are we talking about? So I have a picture down here. This would be a metal. This would happen to be sodium here. You can see sodium has 11 positives in him. 11 positives. Sodium, if you look on the periodic table, has 11 protons. And when he is an atom, he also has 11 negative electrons. And so he has an overall charge of 0. On the other side here, I have fluorine. If you look at fluorine on your periodic table, he has an atomic number of 9. So he has 9 protons. And he will have a charge of 0 with 9 electrons. That's how they come normally. These elements are not stable like this. They're neutral, but they're not stable. Okay? Now, when you are talking about bonding, when you're filling up your electrons, remember you can put 2 electrons in the first energy level, 8 electrons in the second energy level, and then 8 electrons in the third energy level. Okay? So if you take a look, we have 2, so we need 11 for sodium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is 1 extra valence electron. Right? Or you can just say, hey, let me look at my periodic table. Sodium has 1 valence electron. The only electrons you're allowed to use in bonding are your valence electrons. So that sodium has 11 electrons, but he only has 1 he can bond with. Silly old sodium's only got 1. Fluorine has 9, so he's going to put 2 in his first energy level, and then he's going to put 1, 2, 3, 4, 5, 6, 7 in his outer energy level. So how many electrons does sodium have to play with? He has 1 valence electron, and like I said, you can either count it there or fluorine here has 7 valence electrons. Wrong way. Okay? So again, just remember, valence electrons are the electrons in the highest energy level, and you look at the group number. Now, what happens to make a bond? There's a brand new rule. It's called the octet rule. Probably give some stuff away, being the octet rule. Atoms will gain or lose valence electrons to get, how many do you think if it's an octet rule, like an octagon or an octopus? Yay! They want to get 8 valence electrons. Sorry, a full outer shell of 8 valence electrons. Atoms will gain or lose valence electrons to get to a full outer shell of 8. There's always an exception, but there is one element that is super happy only having 2. Helium only wants 2 valence electrons. He's very stable. And hydrogen only wants 2 valence electrons because he's just trying to fill the first energy level. And the first energy level, S, is full with simply 2 valence electrons. So always got to have an exception. Oh, here, further down. Except 1s is filled with 2. Hydrogen and helium are happy with 2 valence electrons. Everybody wants 8 except hydrogen and helium. Okay. Once you have a full outer shell of 8, you are stable when it is a full outer shell of 8 valence electrons. So the goal of every atom's bonding experience is to try to get to 8 valence electrons. Let me show you a little bit about what that's going to look like here. Okay. All right, so let's write the electron configuration for sodium. So if you have your periodic table, you can jot it along with me. Sodium is 1s2, 2s2, 2p6, 3s1. Fluorine, might as well just fill them all in and then we can go through and talk. Fluorine is going to be 1s2, 2s2, 2p5. Hopefully you guys all know how to do this. You did this on the test last week. All right. Magnesium, if you see him, he's a 12, 1s2, 2s2, 2p6, 3s2, and then oxygen, he has 16, 1s2, 2s2, 2p4. So let's take a look at an electron configuration level, what a bond is going to do to an element. Are we ready? It says, please circle the valence electrons. And we said the valence electrons are the electrons in the highest energy level. So if you are circling valence electrons, that means you circle the one with the highest number in it. For sodium, the valence electron is 3s1. Okay. For fluorine, the highest energy level is 2. So they're going to have anything with a 2 in front of it. Those are your valence electrons. So what do you think you're circling in magnesium? The 3s2 and oxygen here. Okay, let's add these up. So sodium only has 1 valence electron. That makes him very sad because he wants 8. Fluorine only has 7 valence electrons. He's also sad because he wants 8. Magnesium only has 2 valence electrons, also sad. And he has 6 valence electrons. Everybody's sad here. Let's see if we can't do something to make this a little bit better. Okay, sodium and fluorine are going to go through a bond. What sodium is going to do is sodium's going to say, you know what, I don't even really like this one. Like this one, I don't like it. Okay, so if I got rid of this electron, remember we said that metals like to get rid of their electrons. So what sodium is going to do is he's going to say, you know what, no thank you. I don't want that 3s1. So on your paper, I would cross him out lightly. And if you don't have the 3s1, if you were to now circle his valence electrons, what valence electrons does he have? 2s2 and 2p6. So if he got rid of that, now how many valence electrons does he have? He has 6 plus 2 is, oh, you turn that frown upside down, you do. Now he has 8 valence electrons, so he's happy. Fluorine just happens to be nearby and says, wait a second, wait, I have 7. If you don't want that, pop that bad boy on here, make this 2p6, and how many valence electrons do I have now? Boom! Everybody's happy. Okay? And you can do that in more than one, and sometimes that's where it gets a little complicated. You can have more than one singleton. You can have lots, so we're going to get into this here. We can do the same thing with magnesium and oxygen reacting together. You know, magnesium, he says, do I really want these two? I don't want these. I don't want, no thank you. I don't want that. So I'm going to take this away. If I give away my 2 valence electrons, now I can fill my second energy level. Woo, I am happy. Okay. And let's give you those. Boop. Now, the only thing that you have to then think about is what that does electrically to the charge when you give and take electrons. So let's go back up here, and then we'll do these ones down here in just a second. Okay, so sodium could say, hey, listen, I don't want this extra electron right here. You know what? I'm going to give it to you there, fluorine. So, but if I get rid of an electron and now I only have 10, am I still a neutral charge? Plus 11 minus 10 gives me a charge of what? Plus 1. Okay. And if my nonmetal takes in an extra electron, so now I have 10 of these bad boys, my charge would have to be what? Beautiful. So as soon as you transfer an electron or 2 electrons or 3 electrons, whatever, you immediately change the charge. Okay. So down here, sodium's lost an electron, so he's not 0. And we'll practice doing this charge here in a second. Fluorine, he gained 1, so he's going to be a -1. So as soon as you transfer an electron, you get a charge. Let's talk about what kind of charges we're going to get. It says make sure you put the stable charges on your periodic table. So let's do this. Are you ready? Get your nice periodic table out. This is something you're going to want to put on your nice periodic table. All right. All right, here we go. Everybody in group 1. Here's the, you don't have to write this down. Let's just look. The electron configuration for lithium is 1s2, 2s1. All of these are going to end in 2s1. All of these have 1 valence electron. Would it be easier to give away 1 electron or try to beg for 7 more? It's easier to just give away 1. So everybody in this group is going to bond by giving away their 1 electron. And if I have 1 less negative, that means everybody in this group is positive by 1. So let's write a +1 right at the top here. They're stable, and you want to write this off to the side, you can. Their stable charge, everybody in group 1, is a +1. Okay. Everybody in group 2, we're trying to get to 8. Everybody in group 2, is it easier to give away 2 or is it easier to beg for 6? It's going to be easier to give away 2. When everybody gives away 2 electrons here, everybody, I'm talking beryllium, magnesium, calcium, strontium, barium, radium, they're all stable with a +2 charge. Okay. We're going to skip the B block again. Everybody in group 3 has 3 valence electrons. They're going to just simply give those away. Everybody in group 3 is stable with a +3 charge. Now things get crazy. Group 4, you got 4 valence electrons. You're halfway there. You might give away 4 electrons and become +4, or you might take 4 electrons and become -4. Both of those are plausible. So what you're going to write is a little ±4. You would have to have more information about the element that you're bonding with in order to know if it's a positive or a -4. Okay, so we'll avoid that guy for a while, but then eventually we'll get there. Okay, now remember, we always said that the nonmetals like to take electrons and become negative, correct? And in your little paper here, we just said if you take extra electrons, you become negative by how many you take on. So let's take a look. So 1, 2, 3, 4. If you have 5 valence electrons and you're trying to get to 8, how many more electrons are you going to take in? You're going to take in 3 extra negatives. So that makes you negative by 3. Everything in group 5 is stable at a -3. In group 6, how many electrons do they need to steal? They need to steal 2 to get to 8. So they're all going to be -2. And in group 7, one of the reasons why they are so stinking reactive is because they are so close to having 8. If they have 7 valence electrons, all they have to do is steal 1. So they're going to be a -1 charge. So everything in there. If I said, hey, what's a stable charge for iodine? You'd be like, whoop, 1. Now, noble gases. Do they give electrons? No. Do they take electrons? No. Do they share electrons? No. Do they do anything with their electrons? No. So what is their charge always going to be? You got it. Okay. So now you've officially written that on your periodic table. That is something you want to commit to memory. 1, 2, 3, 4, 4, 3, 2, 1, with a 0 on the end. It always is the same with the group. So what's the most stable charge for gallium or germanium? I'm sorry, plus or minus 4. Most stable charge for strontium, plus 2. It's easy. Okay. All right. So the bottom line, when the octet is full, the atom is stable. Full means 8 valence electrons for most, but then 2 for hydrogen and helium. Okay, so let's get you guys practicing a little bit so that then we can get into more specific stuff tomorrow in our lecture video. I have a worksheet here. The front half of it is like just review of what we just did, so I'm not really going to make you do it again. The only thing I do want to remind you are some parts of your lecture questions here. Atoms give or take electrons to become stable. You probably don't have to rewrite that. Another thing that I do want to talk about here very quickly, and so you don't have to write this either, one of the confusing valence electron things would be like krypton. If I had you circle the valence electrons in here, it would be the 4s2 and the 4p6. Remember, we're looking for the highest energy level. Okay, I don't think that's super hard to understand, so I'm not going to belabor that point. But if you're circling the valence electrons, you're circling the one with the biggest numbers out front. And remember, they always want to get to 8. Does krypton happen to have 8? 4s2, 4p6, that's 8. What group is krypton in? He's a noble gas. And so, yeah, he's already stable. He doesn't want to give an electron. He doesn't want to take an electron. He is happy with his 8. Okay? All right, so what I really want to do is I want to turn this particular paper over and start to have you guys start to draw bonds. In this unit, there's a lot of conceptual drawing. People either love it or hate it, but when we were approached by upper-level secondary teachers, professors, things like that, they said, it's nice if they know that potassium and iodine can react, but what's really nice is if students can see what that would look like. Okay, so there's a lot of drawing in this unit. So we have 2 elements, potassium, K, and iodine, I. Using your periodic table, how many valence electrons does potassium have? Not the charge. How many valence electrons does potassium have? Got 1, right? So I'm going to go ahead and you can just use your little pencil. I'm going to put 1 valence electrons by here by potassium. And how many valence electrons does iodine have? 7. All right. And it says, please draw what will happen with the valence electrons when the following elements react to satisfy the octet rule. Tell what charge the elements will now have once the electrons are transferred. So you can probably see potassium doesn't like to have 1. Iodine doesn't like to have 7. So all I need you to start understanding right now, we're starting our understanding, so I hope this seems really easy. This electron is going to go over here to iodine. Boop. And if I lose an electron, potassium is going to become +1. And if he gains an electron, because that's gone, he is going to become -1. Okay. Let's try one that's harder, shall we? Anybody have any questions on that first example? All right, lithium and oxygen. Lithium, oxygen. Lithium is in group 1, so he has 1 valence electron. Oxygen is group 6. 1, 2, 3, 4, 5, 6. Now, here's your first challenge. Does lithium 1 has 1 valence electron? No, he does not. So I'm going to take this 1 valence electron. I'm going to give it to oxygen. Okay. Lithium becomes stable with its +1 charge. However, is oxygen all the way stable yet? Tell me.
We don't have that one.
What? What is your next one?
So you make that one.
No, it's too easy. Lithium and oxygen. Oh my gosh. Okay. Oh, that's a good idea. Or thanks for letting me know so I'm not like, that's a good idea. Yeah, I'm sorry. Lithium here. We cross off sodium and chlorine. That one's like really easy. It's a 1-for-1. And right, lithium. That's up there. Thanks for letting me know that. There you go. Lithium and oxygen. Now, we have our lithium is fine with a +1 charge, but oxygen here has how many valence electrons? 1, 2, 3, 4, 5, 6. Is oxygen happy yet? He only has 7 valence electrons so far. How many does he need? 8. Everybody needs 8. So what if there was another lithium? So what you're going to have to start doing tomorrow is we're going to have to see how many multiples we need of each in order for them to bond and be stable. So if lithium has another electron here, now oxygen took an electron from each of these lithiums. So what is oxygen's charge going to be? Going to be negative by 2. Okay, and you can check because you see he's in group 6. Let's see, do we have magnesium and iodine? Hot dog, we're back on the right one here. I'm also taking off the easy example and put a harder one in there. All right, magnesium, Mg, and an iodine, I. How many valence electrons does magnesium have? Yeah, 2. How many valence electrons does iodine have? 7, 2, 3, 4, 5, 6, and 7. All right, here's another tricky one. What do you think we're going to do? It's like a puzzle. It's fun. How many more valence electrons does iodine want? He has 7. He only wants 1 more. He's not taking 2. I don't want 2, he says. He says, I only want 1. So magnesium is going to give 1 electron to that iodine, making him a -1. Is magnesium happy now, though? Oh, what do you think we might need another one of? Let's get ourselves another iodine, shall we? And then he also needs 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Oh, there we go. So now this magnesium is going to give an electron to him. He's happy again as a -1. And if magnesium gave away 2 negative electrons, that means he is positive by dose. Beautiful. Okay, so I've done half of these for you. There is one that's a little more tricky, the last one. Let's see if you can't figure that bad boy out. But what I want you guys to do for the last 10 minutes here, finish the back and the front of this. And I'm giving you some time to do those lecture questions since I always forget to tell you to do them. Lecture question it up, okay? The key to this, see it, is in the week 21 chemical bonds. The key to this worksheet is in the folder if you would like to check it, okay? So I'm going to walk around the room here, make sure everybody's good. I'm going to bother you people at home, make sure you guys are good, get your credit for being here. See if you can't figure out, the last one is a little challenging. See if you can't figure out how their electrons are going to kind of move there. And we are taking this a step further into ionic bonding tomorrow, okay? And we're doing some naming issues tomorrow, which are going to start a really fun series of 3 notes on naming, okay? Perfect. All right. So again, finishing this worksheet, also making sure that you take a look at your lecture questions for today. So fire up your laptops if you would.